Heathrow. The interesting thing about it actually is that whereas a lot of our exhibits are kind of standalone machines which speak to computer scientists, this is really a complete system, and it's a whole environment. I think that makes it particularly interesting for us. Ben is also laying plans at the moment to have a gallery on high performance computing, which again will focus on applications like weather forecasting and so forth. That's not yet funded, but hopefully they can happen. Anyway, I'll hand you over.
Thank you, Martin. Thank you. So hello everyone. For those of you who don't know me, I'm Ben Trethowan. Unfortunately I wasn't able to attend the conference yesterday because I was at work, as Martin pointed out. I managed to get an escape pass for today. So I'm going to talk a bit about the Iris machine, which again you'll see later. I won't delve too much into the technical detail now. I'll talk a bit more about the restoration, the reconstruction aspects now. It makes more sense that I've got the physical machine to point to later when we're coming around in your groups. You will see a few pictures come over. The first thing I will show you though is a little video which is the first playback that the system performed after having restored it back in 2008-2009. So a kind of seminal moment there. After all the hard work, you start seeing aircraft move around on the radar screen. Of course you'll see Iris later. But that's what we were working towards. That's what it's all about. Getting it back to that stage. There we go. So yes, I'm going to talk about Iris. Iris is the independent radar investigation system, which sounds fancy, but all it really was a radar playback facility for investigating air traffic incidents. And it was located at West Drayton, which some of you may know is the former Air Traffic Control Centre. It's now moved to Swanwick, down in Hampshire. But the system itself was designed and built in the early 70s. I think it entered service in 1978, if I recall correctly, and was in complete full service, totally used until 2008. So that's a pretty long lifespan. In fact, I think we went to NATS, National Air Traffic Services, when they were still based at West Drayton, in possibly slightly before 2008, to research getting the system donated, etc. And when we got there, they said you can't have it, we're still using it. You come back another day. So yeah, we managed to get off them eventually. And there is a system post-restoration in a lovely glossy photo shot. I recognise some of the people in that picture. Yeah, so like I said, I'll talk a bit more about the technical aspects of behind the machine and its architecture, etc. Both in a minute, but also a lot more later when we see the machine physically as well. And a bit more about capturing the system, getting hold of it, getting hold of the information about it, etc. Because as Martin said, it really was complete when it was presented to us in the fact that it had all the peripherals we needed, it had all the software we needed, it had an application, we had the data for it to play back, etc. So it was kind of a gift-wrapped application, gift-wrapped, viewable application of computing, if you will. And the importance of capturing everything when NATS offered it to us was absolute, because they had bulldozers on the site waiting to level the building that all this equipment was in, because they'd sold the site. I think they were turning it into housing or something like that at the time, and literally the builders were parked outside waiting to demolish the lot. So we had a very short time frame to capture all this, and also if we didn't, then it would no longer exist. So we had to make sure we got as many spares as we could, all the documentation we could, the software we could, etc. Because it is a custom-built system just for them, manufactured by Plessy. We'll talk about that in a minute. And if we lost it at that point, we were never going to get it back. So you can see here some of the important points, and obviously we said, as mentioned, that some of the hardware was custom modified by Plessy, all of the schematics, etc. they had to give us, but we had to take them there and then. The display hardware was custom built by Ericsson for them. They had all the Ericsson engineering manuals, but we had to take them there and then. An awful lot of documentation. The user interface hardware, you'll see some of the screens and stuff later. The controllers used to input data were all custom designed by NATS and built by a company called Baco. Again, we used to take all the spares we could then, you're never going to find them again. Same for the operating system and some of the system software that Plessy designed. And also for the recording and playback hardware, which is equally important because it's great having a system up and running again and you get a little prompt saying awaiting radar data across the middle of the screen. and there's almost a whole separate restoration project then to worry about how we get the data back off the tapes. And Darren was talking earlier on about some of the aspects of trying to replay, obviously, historic data from degrading media, etc. To make things worse, the radar data that the system handled was again a proprietary format designed by the Civil Aviation Authority, and since fallen out of use, was replaced by a European format. Again, there was one last copy of the specification for that format, which NATS had physically, a hard copy of that format, which they managed to give us, just as well really. And the data itself on the recording systems, again, was stored in proprietary formats to those systems. So we have two systems there, the SE7000 and the RARE system, which we'll see in a picture in a moment. They're not with the machine now, because they're too big, but you'll see them in a minute on the picture. And both of those systems store the radar data, but in completely different formats, proprietary to those manufacturers. It's also important, and it was also important, to understand the system and how it operated in the grander scheme of things in air traffic control, because again, this wasn't something that operated on its own. It needed the radar data input to play back voice data, and was basically dependent on a whole bunch of infrastructure that existed elsewhere within National Air Traffic Services at the time, but of course we either didn't have, didn't take with us, etc., etc., etc. So it did take a fair while for us to sort of become familiar enough with the concepts that IRIS operated within. You know, how does radar data processing work? Why do air traffic controllers need it? Why do they care, etc.? Why is the voice data important? How does the synchronization work? And all those sorts of things in order to be able to mount a restoration attempt in the first place. That extends to the external system dependencies as well. So again, the system would be waiting for inputs before something happens, and those inputs may never arrive because they're waiting for a system that we haven't managed to capture or NATS have retained. And therefore, because of all these kind of complex factors, etc., I think I must have spent the best part of a full-time month at West Drayton as it was being shut down. Luckily, I wasn't in full-time work then, I was studying, so I could afford to take some time out. 4 full-time weeks with their engineers, literally being trained almost as an air traffic engineer at the time, in order to be able to understand the system well enough to be able to package it up, bring it here, open it up, and restore it again. Subsequently, I actually ended up working for that organisation for 5.5 years anyway. So there is the complete system. So just to point out a few of the aspects that you'll be seeing later. Obviously you've got the radar screens themselves over here. We only have one on display now. These are known as the sector equipment groups. Again, there's lots and lots of acronyms. I won't go through all of them at the moment. They'll make more sense later. But we have the screens themselves. All of the processing hardware is based upon PDP-11s, DEC PDP-11s, which I'm sure most of you are familiar with. These two PDP-11s here are responsible for effectively drawing the screens. So they're processing the graphics commands that render the screens and also interpret the flight input data when the controllers were tapping those touch screens there, which we'll see later. And then these two PDP-11s here are more responsible for caretaking the system, overall management and supervision, and also processing the radar data itself. So correlating the radar tracks and then obviously working out where the aircraft position before passing it on to these processors in order to display it. And then these two racks at the end, I mentioned on the previous slides, are the radar playback devices themselves, so they play back the tapes. So here you've got multi-track tape deck there, which was their first record and playback device, and we were given some tapes, but of course they suffered from degradation. They were 30 odd years old, etc., and I'll talk about some of those aspects in a second. And they moved on to this more modern system known as RARE, and that used exabyte tape drives, DAT drives there, although they suffered similar degradation issues. So again, there was some effort required in order to get some playable data in the first place. So once we've got the system back here, the National Museum of Computing, moved it around, unpacked it all, etc. We were lucky enough to have a lot of documentation. Like I mentioned, it was important that we took all that, but again, some things weren't complete, and we couldn't make sense of some other things as well. So some other aspects here which were very important in order to make sure the restoration was a success was the contact with some of the original suppliers of that hardware, which again we were lucky to be able to do because we could find those individuals. In fact, we found a designer of the RARE system, for instance, who was able to give us that insight. So Walton was the company that manufactured the RARE playback system, the exabyte system. Again, it was entirely proprietary software, entirely proprietary format, and again, it was useful being able to call on that gentleman to actually give us the insight that was missing from the documentation itself, and capture that, which we managed to do. Same thing with actually NATs themselves. I mean, the system was installed in 1978 in an air-conditioned, beautifully power-filtered, etc. room. Didn't leave it until it was put on the back of a lorry and then delivered here, and wasn't best pleased about being started up afterwards, obviously considering the environmental differences and a few other bits and pieces. So being able to speak to NATs about that was also very important. There was also some undocumented modifications, so it's fantastic having all the manuals, except the engineers have done stuff and not written it down, which we found as we were going through, looking at the PDP-11s themselves, looking at the backplanes. They've done custom wire wraps to make things work. They've done the same on some of the Plessy serial boards as well, Plessy modified serial boards. Again, not put those changes back into the documentation. I think the only hint we had that was something that had happened was the fact that we actually had the original training notes from one of the engineers that was handing the system to us. So when he was trained on the system 30 odd years previously, and at the start of his career with NATS, he started making notes of the fact that this schematic is actually slightly wrong because there's a wire here that was put in for this thing on this day. And it was really because he'd just done those kind of hand-drawn annotations to help him understand the system that we saw, but the fact that it wasn't meant to be there in the first place wasn't matching the Plessy schematics themselves. So I mentioned some of these challenges earlier on. The degraded playback media was a big one, and it did take quite a while to get over being able to restore the playback devices enough to be able to recover the data. And Dewa mentioned kind of similar experience with the exchangeable disk drives on the 2966. I mean, we only have the tape media to deal with, that's all we had data on. The SE7000, which was the big multi-track reel-to-reel device. We had some tapes, however, because they were old, they were suffering from oxide separation, so obviously the oxide layer was coming away. There are ways around that, but we didn't feel that would be appropriate to attempt on that particular media. We did have also some playback media that was available for the rare system, which was the slightly more modern exabyte devices, exabyte tapes themselves, although the cartridges had degraded. So the exabyte cartridges had started to degrade, but more importantly, the actual drives themselves had started to degrade, so the capstans, the belts, etc., had all started to rot away. Luckily, they are modern enough that we could find some of the replacements, etc., in order to be able to get the rare system running again long enough to play back the data that we had on some of the tapes that NAT had given us and capture on a PC, basically. So we built, again, a custom interface to record that radar data so that we don't have to keep using that system again. The system still operates, but again, we prefer not to use it because we have the data captured now. We can operate Iris by using that data, and therefore we're avoiding, obviously, antagonising the media of the system itself. Yeah, so I think I've spoken a bit about those issues, mechanical issues with the exabyte drives. Again, difficulty in finding spares, and again, luckily enough, the fact that we were a museum, we had other exabyte drives donated just as single units because they were used in other systems, etc., that we could use, swap in and out, etc., in order to find a combination of things that worked for long enough to play back the data. Software issues, and again, we've been through some of these already. Lack of a backup of the operating system. So again, one of the first things we did was we were given an optical disc with the operating system on, and that was immediately backed up, etc. Because there was only one copy. That was the only copy we had. Same for the manuals, and again, we've already spoken about the manuals. The radar data format, actually, when it's played back into the system, is synchronous serial, which doesn't sound particularly extravagant, but is actually quite difficult to work with. So in order to be able to capture that off of the playback system in the first place requires some interesting custom hardware that we built for, again, it's just a Linux PC, just a kind of USB interface, in order to be able to capture that data in the first place and then play it back. We have a future kind of task in order to be able to do the same for the data that goes between the display processor and the display itself, so that we can emulate the displays, because again, we have limited numbers of the parts for the displays. The displays are also difficult to maintain, if anything, in the display assembly goes, in the power and the control logic is fine. but if the tube goes, then we pretty much had it. We do have spare tubes, but no assemblies to try and mount them in to try and take the unit apart and replace the tube, etc. So we're hoping to be able to capture that data as well and basically just build a screen emulator. And again, we can do that because we've got all the Ericsson manuals which describe all of the vector commands and what they do. So that is certainly possible, albeit quite a big task for the future. Yep, so I think we've discussed that. There's a slightly closer picture of the processing hardware, and then so we've got the processing hardware here, and then the playback hardware here. So here's the road unit itself. There's the 2 exabyte tape drives, again we have to restore and swap for like replacements just in order to get the data playback in the first place. The control panel, and you'll see the control panel again later. The interface units and then the outputs, the synchronous serial output channels at the bottom. The SE7000, which is a 7-track multi-track tape drive. Again, we got some way in the restoration of the drive assembly itself. And then we decided it was too risky to try and actually play the media that NAT's given us back at that time anyway, because it was likely to obviously just degrade the media and make it unreadable in the future. And then here we have the RK5 SSD, which is used to load the operating system for the IRA system itself. And again, we've talked about these other units, and you'll see them a lot closer later, and therefore they'll make a lot more sense. So people have been talking about why do we bother doing all this stuff in the first place? And as what I mentioned earlier on, I think the good thing about this particular system, this particular example, is that it was a gift-wrapped set, which A is visually impressive, and B is and was used in a context that people can understand, because people know about air travel, people go on holiday, etc. They've heard of air traffic control, they've seen Heathrow Tower on TV and stuff like that. They've probably even seen radar screens and films, etc. So to be able to have 2 big green screens, obviously plotting radar tracks and aircraft movements, is visually obviously very appealing. Needs to be in, and of course we can start explaining things like the system handled 48 million aircraft movements in its lifetime without a single air traffic attributable incident. So 48 million aircraft movements, and any air traffic incident, or aircraft incidents as they're called, were never as a result of the systems or the air traffic controllers in that time frame, which is pretty impressive. Again, obviously the vital role it played in the transport infrastructure, and people have heard of obviously the air traffic incidents that we have had over the years, and they would have been investigated on IRIS. It was the investigation system and the only investigation system. So they can obviously think about what that system has played back and who has sat in front of it during its lifetime. And again, also, like I just mentioned, just the appearance, and obviously you saw from that kind of glossy photo earlier on that it is quite visually impressive, especially when the lights are good, which was its operating environment. And there we have me stood in the race floor at NATS, pulling the cables out for it, back in 2008. And me and my colleague Peter Vaughan, who worked with me on the restoration, standing in front of it when that video was taken, which was obviously when the first successful playback was finally achieved.
Fantastic, thanks very much indeed. 19.5 minutes, well done. We seem to be making good time. Before I say that, were there any questions?